Hello everyone, myself Amisha Nundi and my ID is 12108051. Today I will present decision tree and one of the most popular supervised machine learning algorithm. Decision trees are widely used because they are simple, interpretable and effective for both classification and regression tasks. Let us discuss about what is decision tree. Um, a decision tree is a supervised learning algorithm that learns pattern from level data and represent them in a tree structure. Each decision in the tree is based on features value, allowing the model to predict outcomes for new data. And it creates a tree like model of decisions and predicts outcomes by learning rules from training data. And another is a basic structure of decision tree. Uh, a decision tree consists of four main components. The root node is the first split. Decision nodes represent conditions. Branches show possible outcomes, and leaf nodes provide the full prediction. And here is the figure. We can see that decision tree start from the root node and we find out the internal node that is actual decision node, and finally we get leaf node, and that is the figure. How decision tree work? The algorithm begins with all training data and repeatedly selects the best features to split the data. This process continues until the data in each node belongs mostly to one class or another. Stopping condition is reached. And finally, we stop when the data is sufficiently pure and assign a class level to leaf nodes. Now, splitting criteria. Splitting criteria actually depend on entropy and information gain. To decide where to split the data, decision trees use measures such as entropy and information gain. Entropy measures disorders in the dataset, while information gain measures how much uncertainty is reduced after splitting. Here, entropy S is equal to minus summation of I is equal to 1 to n and pi log to pi. Here, pi is a probability of class I, and information gain is equal to entropy parents minus weighted entropy of children. And here is the example dataset of play tennis, and this is a simple dataset used to predict whether a person will play tennis. Features such as outlook, humidity and wind condition help determine the final decision. And here is the final result. Based on the training data, the model learns these decision trees. The root features is outlook because it provides the highest information gain depending on whether conditions the model predicts whether tennis should be played. And we can see that humidity has the highest information gain, so it becomes the root node. The attribute with the highest information gain is 0.420, and here final decision root node is humidity. uh, if humidity is normal, then play tennis is yes. If humidity is high, then high and outlook is sunny, then play tennis is no. If humidity high and outlook rainy, then play tennis is no. If humidity high and outlook overcast, then playing tennis is yes. Now, advantages of decision tree. Decision trees are popular because they are easy to interpret and visualize. Unlike many machine learning algorithms, The require minimal pre-processing and can work with different types of data. Although powerful decision trees can overfit the training data, they are also sensitive um, to small variation in data, which can result in significantly different tree structure. And to preventing overfitting, there are some condition. Overfitting can be reduced through pruning techniques, limiting the depth of the tree, or using assemble methods such as random forest, which combines multiple decision trees for better performance. And here is the figure. Why pruning is needed. Sometimes a decision tree grows very deep and learns noise or random patterns from the training data. Here we can see that a full tree without pre pruning and with pre pruning. With without pre pruning, it looks like maximum tree depth reached, minimum number of samples is node, and with pre-pruning the tree stops growing early. And another one is post pruning. The complete tree is first built and then unnecessary branches are removed. Here, grow the full tree, evaluate each subtree, remove branches that contribute like to accuracy, replace them with leaf nodes. And here we can see that suppose the wind split does not improve validation accuracy from the before post pruning, and after post pruning we see that the unnecessary branches is removed. And the applications of the decision trees. Um, Decision trees are used extensively in healthcare, like medical diagnosis, banking, like loan approval prediction, fraud detection, and marketing, like customer segmentation, credit risk assessment, and cybersecurity, like email spam classification, recommendation system, and many other fields where interpretable prediction are important. Thank you. That's all about my part.